Hello everyone. Previously we had discussed on the two pointers algorithm, right? So today we'll be going with the Dutch national flag algorithm, right? So let's see the definition part. Then let's discuss some important points as well. Then let's go with the algorithm or the basic example, right? So just let's go with the definition part first. So the Dutch national flag algorithm is proposed by Edsja Dijkstra, the same guy who proposed this one Dijkstra's algorithm as well within the what do we call graph basically. So Dijkstra's algorithm, you all would have came across the Dijkstra's algorithm if you would have went through the topic graph, right? So the same guy proposed the this one, what do we call, uh, Dijkstra's algorithm as well within the graph topics. These two algorithms are proposed by Edsja Dijkstra, right? So here, the Dutch national flag algorithm proposed by Edsja Dijkstra is used to sort an array containing, again, is used to sort an array containing three distinct elements, right? Commonly zeros, ones, and twos in a single traversal with a constant extra space. Simple, right? So again, it is used to sort an array containing only three distinct elements, commonly zeros, ones, and twos, in a single traversal with constant extra space. It works by maintaining three pointers, low, mid, and high. Easy. Three pointers, this one low, mid, and high. What we are doing basically sorting the array containing only three distinct elements. Just keep these things on the mind. So let's go with the important points first. Let's see how this works basically, right? So imagine we have balls of three colors, right? So one is red, white, and blue, right? Just for the sake of example, let's say red, white, as well as the blue. We want to arrange them in the order, right? So we want to arrange them in the order, red first, then white and blue. Red, we have to arrange red first, then white, then blue, right? So what we'll be doing, we'll be considering low pointer that keeps track of the boundary for the zeros, right? And we'll be going with the mid pointer that traverses the array, and finally the high pointer that keeps track of the boundary for twos, right? So we are going with the zeros, ones, and this one twos. So low pointer, what it does, keeps tracks of boundaries of zeros. For zeros, mid pointer traverses the array, and high pointer keeps track of the boundary for twos. Let's see the steps, right? So we will be starting with the low equals 0. Initially low will be 0, mid will be 0, and high will be n minus 1, nothing but the last element, right? N minus 1 in the sense length minus 1 basically, right? So we'll be going with a zero indexed, right, array basically. Usually we'll be going with a zero indexed array. So here I have given n minus 1, low 0, mid 0, and high is nothing but the last element, in simple terms. So we will be traversing while mid is less than or equal to high, right? So mid is less than or equal to high. So we consider 3 points here, right? So three conditions basically, right? So if array of mid is equivalent to 0, right, is equivalent to the value 0, then we will be swapping that with the array of low, right? So then we will be swapping, if the array of mid, exact middle element, array of mid, if the value of the mid element is 0, then we will be swapping that one with the array of low, right? So then we will increment both low and mid. Just keep this in mind, right? So if array of mid is 1, just give me a second here, 1 second. Yeah, if array of mid, this is fine I believe. If array of mid is 1, so sorry, this one, if array of mid is 1, then we have to move the mid, right? So if array of mid is 1, the value 1, then what we will be doing, then we will be moving the mid basically, right? So then we will be moving the mid. So what if the array of mid consists of the value 2? If it is equivalent to the value 2, if array of mid is equivalent to the value 2, then we will swap array of high, array of high, uh, then we will swap with the array of high, and then we will decrement high, right? So then we will decrement high, right? So this one is for the 0. So we will swap with array of low, and we will increment both low as well as mid. Increment both low as well as the mid. Just remember this one. Increment low as well as the mid basically, right? So just keep this in mind. These three things are very important, man. These are the steps that we'll be following basically, right? So we will be making use of three pointers. One is low, mid, and high accordingly with the algorithm, right? So low, mid, and high. So will initially low will be 0, mid will be 0, and high will be n minus 1, nothing but the last element. So here goes the traversal or logical condition. So these logical conditions are very important, right? So when array of mid is 0, so what we will do, we will swap with array of low and increment low as well as the mid. This is fine. Then if the array of mid equal it is equivalent to the value 1, then we will just move the mid. If the array of value is 2, array of mid is equivalent to the value 2, then what we'll do, we'll swap with the array of high and we will decrement and we'll decrement the high. We'll swap with array of high and we'll decrement high, right? So these three things, just keep this in mind. It's very important, right? So let me remove this one, right? So we'll continue until all the elements are partitioned correctly. What we'll do, we will continue until all the elements are partitioned correctly, right? So this is fine, man. Now we're done with this one definition part of the algo, and we have discussed the steps as well. uh, we saw what are the things that we need to do, right? So we discussed every step. Now let's go with a very simple example or the algo here, right? So I'll just go with def here, touch national flag. So this is fine. Let me consider array as parameters within this function. What was our first step? Basically we have to initialize the pointers, right? So I'll just go with low, mid as well as high. This one is fine. High, let me initialize this one to 0. Also let me consider 0, and let me consider length of array minus 1, right? So this is fine. uh, we are considering low, mid and high to this one 0 0, and length of array minus 1 means low to 0, uh, mid to 0, and this one high to length of array minus 1. Sorry, so did I say high equals 0? No, low to 0, high to 0, and this one low to 0, mid to 0, and high to a length of array minus 1, nothing but the last element. So this is fine. Then as we had discussed in the this one approach part, so we have to traverse until the mid crosses high, nothing but in simple terms this has to be while mid less than or equal to high. This is fine. Now if array of mid is 0, so the three conditions that we considered, let's write in the form of code now. If array of mid, this one I don't have to go with this is Python, right? I get confused, man. Sorry. If array of mid this is equal to 0, then what I'll do within the if condition, case 1 is we have to go with the current element that is 0, and swap with the low. That's what we considered, right? uh, that's what we discussed basically. So this one I'll just consider array of low, array of mid. So this one will be array of mid comma array of low. This is fine. uh, Now I'll just go with low equals low plus 1. Also I'll just go with mid equals mid plus 1, mid equals mid plus 1. So this is fine. Now let me go with the elif, man. This elif part, this one, if when the array of mid equals 1, basically array of mid equals 0 1 2, right? So array of mid, now if it is equivalent to the value 1, then what we discussed actually, if it is equivalent to the value 1, then we have to consider the current element that is 1 and just move the mid, and we have to just move the mid here. So I can just write simply here mid equals mid plus 1, simple, right? So now let me go with the simple else. This is fine. mm, Else, so within the else, let's go with the final this one case. We have to consider the correct element that is 2, and we have to swap that particular element with the high. Basically I can just write it in the form of code in this way. This has to be array of mid comma array of high. This is fair. This one will be array of high. This is also fine, and array of mid. Yep. Now high equals high minus 1. Finally, what we will do, we will return the we will return array, right? So finally, what we will do, we'll return array. So I'll just go with return array. This is fine. We are done with the coding part, right? So we are done with the algo part or the coding part, right? So let's see the this one. Let's go with the test case or the example usage. So I'll just go with array equals. I'll just pass some random numbers here. 2 0 2. I'll just give 1 1 0, something like that, right? So this is fine. Now let's print something for the interactive purpose. So I'll just go with print here. This one will be sorted array. This is fine. Now the function name Dutch national flag. So of the parameter that we considered, right? So array ARR we have considered in the previous line. So this is fine. Uh, Now what is the output that we need to get here is basically sorted array we have to get, right? So 00 11 22. So everything we have considered twice, right? So numbers we have to get the sorted array basically. So that is the reason we have to get the sorted array. That is the reason we have made use of the Dutch national flag algorithm. So that is the reason we make use of the Dutch national flag algorithm, right? So this is fine. Now this one, just give me a second. So here low mid high equals 0. So this one, what we have done, we have set the boundaries at the start and end of the array here, this line, right? So while mid is less than or equal to high, this is nothing but we are processing the elements until mid crosses high, right? So this is fine. So these three conditions we have already discussed: array of mid equals 0, array of mid equals 1, and finally else I have made use of. This is basically when array of mid equals 2, right? When 0, we are putting it on the front, nothing but we are swapping with low, right? So then move both the pointers. If array of mid equals 1, this part line number 36, if it is already in the middle, then we have to just move forward. So the final one, if array of mid equals 2 means we have to put it at the end. Basically we will be swapping with high. Basically we will decrease the high, right? So we will decrease the high. So finally we will return the sorted array. So basically we have considered this example. So example, for the example usage, I have considered this array. So when I run the code, we have to get the output basically sorted array, nothing but 00 11 22, right? So let's see the same. Let me run the code. Python followed by, I'll just right click here, let me copy the file name dot py. So here we are getting the output 00 11 and 22, which is absolutely correct, right? So now this is it for the Dutch national flag algorithm, right? So this was proposed by Edge Dijkstra, right? So same thing, I'm stressing on the name because the same guy is responsible for this one, Dijkstra's algorithm within the graph as well. So we'll be discussing the Dijkstra's algorithm when we discuss graph-based algorithms, right? So this is fine for now. Now, as we are done with the Dutch national flag algorithm, let me summarize whatever we have learned so far. So just keep these three things in the mind, man. First thing is the Dutch national flag algorithm. Basically what it does, it sorts arrays of three types of elements on big of n time and big of one space. So basically I can just write it here. Time complexity is nothing but big of n, and the space complexity is nothing but big of 1. Just keep this thing in mind. So this is important part, right? So again, the Dutch national flag algorithm sorts arrays of three types of elements on big of n time and big of one space. And the second point here is it uses three pointers. We know that's what we have written the algo, right? So it uses three pointers. One is low, another one is mid, and another one is high, just to partition the array in one pass. Simple. The third one is it is efficient and widely used in the uh, basically interview questions involving arrays of zeros, ones, and twos. So we have solved the some of the problems that comes with zeros, ones, and twos using the Dutch national flag algorithm, if you remember. Within by making use of this one, when I was when we were solving the questions with the JavaScript, we had solved some problems basically using this algorithm, right? So also by making use of Java as well, I have solved certain problems, right? So using this algorithm, if you remember, right? So this is fine for now. uh, we are done with the these are the 3 points. Just try to remember these 3 points, right? So we are done with the Dutch national flag algorithm, right? So next we'll be discussing on the merge intervals algorithm, right? So next we'll be discussing on the merge intervals algorithm. For now, this is it. Thanks for watching, guys.